Hey guys, welcome to another edition of Physical Science. Today we're going to talk about something called the Bohr model. So, as a review, some questions you should be comfortable with are things like what are the three subatomic particles? What are their electrical charges? So, things like protons, neutrons, electrons. Remember, protons are positive, electrons are neutral, electrons are negative, and neutrons are neutral. You should know that electrons are the smallest. Protons and neutrons live in this thing called the nucleus, and electrons, those guys live outside in this thing we call the electron cloud. They don't necessarily have any sort of organized shape, they just kind of move all over the place. And of course, this is not to scale. So this is just kind of a review from last notes about atomic makeup. Okay, so because atoms are really hard to see, we've got a bunch of different models. The previous picture that I showed you is just kind of my model of an atom, what I think of when I think of an atom. Here's a model that this dude, this scientist named Niels Bohr, came up with. Oops. Here's what it looks like. It focuses on electrons, energy levels, and valence electrons. So what we're going to be talking about a lot today are these things called valence electrons and just kind of what they look like. This model really only works for atoms 1 through 18. Once you get into atoms 19, 20, and so on, it gets a little bit more complicated, so we won't really discuss those guys. So there's these things called energy levels, and an energy level is just an area where there's an electron. And it's a little bit more specific. What we're going to show you, they're going to look like orbits, but remember, electrons don't orbit the atom, they just kind of fly around all over the place. So this is kind of a very technical definition of what an energy level is, but really it's just an area where there are electrons, and there's 7 of them. We'll really only talk about 3 with atoms 1 through 18. Valence electrons, this is the most important term we're going to learn here today. Those are the electrons that are in the outermost energy level. So if you only have one energy level, your valence electrons are all the electrons you have on that first energy level. If you have 3 energy levels, your valence electrons are the electrons in the third energy level. Let's show you what the Bohr model looks like, because we're going to be drawing a lot of these. Here it is. You've got your nucleus in the middle, and then you'll notice that this dotted line here, this first dotted line has 2 electrons, so that'll be symbolized by 2 dots. This second line can fit 8 electrons, so that'll be symbolized by 8 dots. And this third dotted line here is the third energy level, and that can also fit 8 dots. This is what you'll have to know. You'll have to know that the levels are 2, 8, and 8. There's also a bunch of other energy levels, but we won't really talk about the 18, 18, 32, 32, just because it's not worth it. Okay, so really the Bohr model stops working after the third energy levels, so this is what you're going to have to know. The first energy level has a maximum of 2 electrons. I would draw a picture of this in your notes and write this down. Max of 2 for the first energy level, second energy level has a max of 8, and the third energy level also has a maximum of 8. Please write this down in your notes. Moving on, here's what argon looks like. Argon has 18 valence electrons, so this would have a full first energy level with 2 electrons, 2 dots just like that. A full second energy level with 8 dots, 1, 2, 3, 4, 5, 6, 7, and 8. And then a full third energy level again with 8. So you'll notice how we're drawing out each individual electron. And then in the middle here, I'm saying P equals, and then I'm writing down how many protons I have, and N equals, and I'm writing down how many neutrons I have. This is a Bohr model. You record your number of protons, your number of neutrons, and then your number of electrons in the first, second, and third energy level. That's what you're required to do anytime you're creating a Bohr model. So here's an example of a Bohr model of silicon. It has 14 valence electrons. So kind of a fun fact is if you add up 2 and 8, you get 10. So think, okay, I've got a full first level, a full second level, and then 4 on the third level. That's kind of helpful. You would really only know that silicon has 14 electrons if you looked at the periodic table, and you'll see next to its atomic number, it's got an atomic number of 14. The question down here asks, how many valence electrons does silicon have? It has 4, because our third energy level is our outermost. and we have 4 electrons there. Up next, we've got nitrogen. Nitrogen has 7 valence electrons. It's got 7 electrons. So it's got 2 in the first energy level and then 5 in the second energy level. So we are going to just count the blue electrons when we're figuring out valence electrons, and that adds up to 1, 2, 3, 4, 5. So we would say that it has 5 valence electrons, or VE. Lastly, we have helium. Helium just has 2 electrons, 2 protons and 2 neutrons. So in terms of number of valence electrons, we would say its outermost energy level is the first energy level. So it's got 2 valence electrons. Since there's nothing in the second or the third, its outermost is really only the first. So you wouldn't even have to draw the second or third dotted lines. You could just get rid of those. Okay, here's your opportunity to draw some Bohr diagrams. Here are 4 Bohr diagrams we want you to make: lithium 7, carbon 14, and oxygen 16. Remember, the 7, 14, and 16 talk about the atom's overall mass. So for lithium 7, make sure you have a total number of protons and neutrons that add up 7. For carbon 14, make sure the protons and neutrons add up to 14. And for oxygen 16, make sure protons and neutrons add up to 16. For lithium, carbon, and oxygen, you're also going to need to use your periodic table, just because that's going to tell you how many protons they have. And also, protons and electrons are always the same, so it'll tell you how many electrons each one of those have. Great, let's go ahead and try these out. Here's lithium. I put 3 protons, I put 4 neutrons, and then I drew 2 electrons in the first energy level and 1 extra electron in that second energy level. So in this case, lithium would have 1 valence electron. Also notice that, oops, I don't know why that got rid of it. Notice that I have 3 protons. 3 protons because it's lithium. Remember, the number of protons you have dictates what the element is. And then I have 3 plus 4 neutrons to get 7. I couldn't have 4 protons and 3 neutrons because instead of being lithium, that would be beryllium. Beryllium has 4 protons. Here's oxygen. Oxygen has 8 electrons. It also has 8 protons. So in this case, we were looking for oxygen 16. So 8 protons because it's oxygen. It couldn't be 10 and 6 because 10 is neon, for example. And 8 plus 8 gives us an atomic mass of 16, which is what the question asked for. It asked for oxygen 16. Looking at valence electrons here, I would say that this has 1, 2, 3, 4, 5, 6 valence electrons. Lastly, we have carbon. Here's what carbon looks like. It's got 6 protons and 8 neutrons. We wanted carbon 14, so 6 plus 8 gives us 14. 6 because it's carbon, and 14, like I said. The number of valence electrons here, we have 1, 2, 3, and 4. 4 valence electrons for carbon. Great, that's all the notes I had for today. Hopefully this makes sense. Hopefully you guys feel better about this stuff. Thanks for watching. Have a great day.